Great, thank you. Let me just put that in presentation mode. No, it doesn't do what I want. I should have tested this. I can't remember how to make it present to the screen. View.
There is a button below, I think.
Yeah, but it's presenting it to my other screen. So, well, I can do that. I can share the other screen if that works. So I'll stop the share and start again. Okay, share 2. Let's do it that way. Okay, you should be able to see it now. I can't see it so well, but okay. So that means I'll be looking down, unfortunately, because it's a different screen. So yeah, I'm Alan O'Cash. I'm the technical manager from MultiXscale. I just want to give a brief mention, so it's a very, very short talk, just a couple of slides about this. Well, it's been mentioned a couple of times already, right? The continuous integration and continuous deployment services that EESSI enables. And these are interesting things to discuss because when it comes to thinking about things like best practices in software development, these are critical components of that. Certainly the continuous integration part, but also how you get continuous deployment. Continuous integration, probably people have heard it before. Continuous deployment is a bit more of a fluid term. Sometimes the CD can mean continuous deployment. Sometimes it can mean continuous delivery. And what that exactly means is a bit fluid between different communities. So in our case, what we mean with continuous deployment is thinking about it from the perspective of production or pre-production software, right? So in the sense that like you have something that's near ready and you want to deploy and test that, or you have something that's production quality and then you want to deploy the production code, right? So that's how we think about it right now. So I'll talk about those services in the context of 2 applications, so ESPResSo, and then something that uses ESPResSo as a dependency called pyMBE as well. Let me move forward. Okay, so going back to what was one of the things that we talk about within our project is this idea of the 3 Ps, right? One of those Ps, so performance, productivity, portability, right? So thinking more on the scientific side, from a scientist perspective, right? From a software and application developer's perspective, we're thinking about productivity, right? So from the developer's perspective of that, we want to think about things like they're developing their software, they get it ready, but then they want to get it into the hands of their end users, right? And they would like that process to be as straightforward as possible. Everyone would, right? Ideally, when you have a production piece of code, it just goes out there and is usable by everyone. But usually the process is not that simple. I mean, especially when we talk about like multi-node applications, right? Which use something like MPI. Historically, at least, compiling an application that uses something like MPI to do multi-node communication means that you have to recompile that code for the platform that you're using it on, right? There's no such thing as there's not really such thing as a portable binary. The portable binary thing is a little bit better now because of the growth of things like containers. And we are leveraging that capability within EESSI as well. But it's been a difficult thing to do, right? So for you as a developer, it's a problem for you, right? But also for your users, it's a problem for them, right? Because they need to build that software, which is a complicated process, right? And so, or can be a complicated process. Sometimes it's nice and simple. If you have a Fortran application and you have no dependencies, all you need is a compiler, and away you go. But in the environment that we live in and compute in these days, that's usually not the case. Usually we're talking about hundreds of packages, right? And we saw that already when Kenneth loaded the ESPResSo package. We saw that he didn't just get ESPResSo, he got like something like 60, 70 different software packages that he had to have available, right, to be able to run that code. So if your users have to have that similar type of environment, which means those 70 different things that they need to be working together in unison and to get that environment, that's a complicated issue, right? And so for developers as well, we also saw that all those other things that are not ESPResSo, but are necessary for you to build and run ESPResSo, they're the dependencies, and they're there, right? So EESSI provides those as well. So it gives easy access to developers to all those dependencies that they need. And that in turn facilitates continuous integration. Continuous integration being that when I make commits, I run some sort of testing to make sure that my commits don't break my code, right? So the primary thing would be that it still builds, right? And that I can still get an executable out the other side, something that I know, and then I test that, right? So then I have some testing to ensure that the binary, the executable, the application that I get out the other side actually works, right? And so that's a continuous integration, and then testing on top of that, and testing on top of the builds that you make. So thinking about EESSI in those CI environments, so in general, EESSI enables portable workflows. So if you're using lots of different applications, and those applications are supported with EESSI, then you have a portable workflow, right? So including like the tools that you use to run that workflow. So for example, we ship Nextflow, we ship SnakeMake, and these are very common ones, say, for different communities, right? But there are lots of other, especially in the HPC space, there are a ton of workflow tools out there. But we can actually ship those tools as well. So not only are we shipping the tools that you would use to run a workflow, but we're shipping all the software that you need to run that workflow as well, right? So EESSI enables this idea of portable workflows, that you can take your entire workflow and be able to run that on different CPU architectures. Now, continuous integration itself is also a workflow, right? So it's no different, and conceptually, it's not different from a workflow. Basically, you need to do certain things. Excuse me, you need to compile your code, right? You need to test your code. So you need all the tooling that is required to do that. And so that's also a workflow, and that's what CI does. So we put a bit of work into making this available. So EESSI is already available in the most, or not all CI environments, but it could be supported within all CI environments. But the two big ones, right? So GitHub, it's available as a GitHub action in the GitHub marketplace. And so the link is in the slides, and you have access to those later. But also GitLab, right? So you can have it in like the public GitLab, right? So the gitlab.com, it's available there. But because it's available within GitLab, you can also have that under a private instance, right? So you can make essentially what's essentially a clone of that, it's a repository effectively under GitLab. So you make a local copy of that, or you can actually use the remote one, I believe, as well. I haven't actually tested that, but in a private instance. So if you have, for example, your institution has GitLab, you can install the EESSI, what's it called, in a component. It's called a component under GitLab. So you can install the EESSI component on your private instance of GitLab and be able to use it there as well. So ideally, that should work as well. So we have tested that, and I'll show you an example in a little bit. So we can provide different compilers that you want to test your software with. Right now, so you need to remember that we are distributing software here, right? So that comes with restrictions, right? So you have to think about what we are allowed to distribute, right? So we need open source software, typically need open source software, and we need the rights to be able to distribute that software as well. So typically we're talking about open source software. Right now, the compilers that we use are GCC, but we are very heavily looking into Clang compilers at the moment, especially because the Fortran compiler under Clang is getting pretty mature. Especially in an upcoming release that's coming in February next year, and it will be considered mature, right? So we're heavily looking into the Clang compiler as well. So you can think about that we would offer different versions of those compilers, right, within EESSI. And then we have different MPI runtimes as well. So obviously there's what we support right now, which is OpenMPI. But then typically at a lot of sites on a lot of machines, you will have what's called a vendor compiler. So that's usually built on MPitch, which we don't have a tool chain for right now, but we're also working on that. So the idea is that we will mix and match those things to make different tool chains available that you can use for your code. And then you will have dependencies, right? Just like we saw for ESPResSo, there's lots and lots of dependencies required to be able to build and run that software. We can provide those dependencies as well. And then there's additional tooling that may be useful for you as part of this workflow, right? So we have a testing framework that we use ourselves called Reframe, and that comes out of CSCS in Switzerland. And we use that quite heavily for our own testing infrastructure. And you can have performance analysis tools. So there are other MultiXscale is a center of excellence in the EuroHPC space. And there are quite a few more of center of excellences, and one of those is a performance optimization. I'm not sure what the other P stands for, probably profiling or something like that. Not quite sure. But they have tools, right, to allow you to analyze the performance of your code. And we ship some of those tools, and we started doing experiments with our tools. And we did it for a particular package that comes out of BSc called X-Ray, but we could, of course, do it for other packages as well. So we could provide all the tooling that you need to also analyze the performance of your code. Other than CERN VMFS, you don't need to do any installations, and everything is, like Kenneth showed, is streamed in on demand, right? So once the package is available under CERN VMFS, you don't need to do anything further. It will just be available as a module. You need to load that module, and then all the binaries are there, and they will be streamed. What you need to run that binary will be streamed in automatically. So everything is pulled in on demand. So what does that look like? So I don't know how familiar you are with the YAML syntax. It's just a syntax for files. So I'm not going to explain it, but just to show you here, basically on a GitHub action, and this is a simple example of what a GitHub action would look like that uses the EESSI action. So basically you give it a name, you say in what scenarios you say under what scenarios it applies, and that's like here, this means a push or a pull request. So pull request is like the software, in terms of software best practices, that's the best way to develop your code. And you don't make direct changes, you make a pull request. It's called a pull request in GitHub. It's called a merge request under GitLab. The idea is the same, that you make a proposal to change the code. That proposal is discussed, maybe additional changes are made, and then when everybody's happy and all the tests are passed, then we merge that into our application. So we know that there's a stable branch to our application that is guaranteed to pass a certain set of tests, right? So that's the approved way of doing, or consider like best practices in terms of code development. And you can tell it on what kind of operating system you want it to run on. And so in this case, all of the ones under well, there's Mac OS as well, but they're under GitHub. The public ones are all Ubuntu. And you tell it to check out the code, and then you just tell it to use our GitHub action. And this one here in particular is using the head. So the most recent version of our GitHub action, but you can stick to particular versions as well if that's what you want. There's an option. It's actually optional right now, but you can tell it what version of the EC stack that you want to use. So right now there is only one option here, and that's all we have right now under EC. But this will change, and it will likely change soon. That there will be more options available here in terms of the version of EC that you use in your stack. So the default will always be the latest one that we make available. But then if you want to stick with an older version for whatever reason, you can do that. So this is just a test that tests ESPResSo by EC. So you need to tell it that it's using a bash shell, because we use some tricks inside the GitHub action to make sure that everything works. So you, just like Kenneth did, you load the ESPResSo module, and then you will be able to run an example of the test ESPResSo code, which is available within the repository where this action is. Okay, so that's a simple version of how easy it is to use the EC GitHub action, right? You need very, very little to set up the environment. You just need a couple of lines. In fact, in a minimal case, you just need this one line and the users part, but then you can select different variables for the action as well to decide on different behavior. In terms of GitLab CI/CD, it's not dissimilar. It's the same kind of YAML syntax. In this case, you need to include what they call a component. So this, you need to give this a value here. This FI server fully qualified domain name, that means the server that you're on. So in GitLab.com, this would work. I think you could use the one from GitLab even in a hosted action, but I haven't actually tested that. So rather than give this environment variable, you could actually give the full URL, but I haven't tested that myself, so I'm not sure. But basically, this is all you need to do to include the component. GitLab CI is a little bit different. I mean, it has different stages, and that what you get after running a stage of GitLab CI is an artifact. So you always have to pass information somehow between the different stages. In this case, all I'm interested in is a little map that I get out from running this action. So this particular piece of CI, it's a subject of a blog post from EESSI. It's available on the EESSI blog, and we've also put something up on the MultiXscale website about this. But basically, all it does is it runs a little R code that one of the MultiXscale people developed. So basically, what it does is it creates a directory to store the R libraries, the additional R libraries that we need to install. It sets an environment variable to that directory. It loads the modules that it needs. In this case, it just needs a bundle of R packages, and then it runs the R code that it needs to run, right? So it installs a couple of additional packages. I don't know much about them, right? But the one that was developed by us was this one, the one by Pedro. And all it does is create a map. A map of Europe, singling out all the countries that are involved in multiscale with a particular color. Right, so that's what that one does. So that's the same thing again. All you needed to do to be able to use this was to include this component, and all of the software that's available at EESSI is available. Looking specifically at what pyMBE does, yesterday I looked at how they set things up, and it's a little bit interesting. So you can see that I've shortened it a little bit here. It's a bit more extensive in their actual repository, but the effect doesn't change here. So basically, they set up EESSI using the EESSI GitHub action, and they have their own action which does a few extra things. So its name is to install the dependencies. What that does is it tells it which modules it needs to load to give the environment that it wants. And just like we saw in R, this little additional action that they have installs additional packages. So it has a couple of Python packages that it needs to run its test suite, right? So I don't know. I know some of these Python packages, but not all of them. And then basically it runs their test suite, right? That's what it does. So effectively, they're leveraging EESSI to provide all of these dependencies. Not all, actually. So EESSI provides the modules, but then they have some additional Python packages that they install directly themselves. And yeah, that is it in terms of the EESSI CI. So I think we will, Mate will take over now for the Q&A.
Yeah, thank you, Alan, for the presentation.